so let's summarize what we've learned so far. You should know that matter is going to be composed of quarks. And then you also need to have leptons as well. Okay, then we talked about what antimatter is. We've talked about what dark matter is. We've talked about what dark energy is. And then we've talked about what causes the four fundamental forces is an exchange particle. And then we talked about those exchange particles were, like, for example, the graviton causes gravity, the gluon causes the strong nuclear force, the photon causes the electromagnetic force, and then the weak bosons created the weak nuclear force. Okay, now the next thing that high energy physics people found when they did all their calculations was matter should not have any mass to it. So according to the Standard Model, and the Standard Model is our current understanding of how nature works, all particles should not have any mass associated with them. Now, for example, the photon, which is the carrier of the electromagnetic force, it does not have any mass. Neither does the graviton. So there are some particles that do not have any mass, but quarks do. And so, for example, quarks need to have mass. So what is it that gives the mass to the quarks? So that's what the Higgs boson does. So I'd like for you to watch this little video, The Higgs Field Explained by Don Lincoln. So watch that. Okay? So let's try to explain what does the Higgs boson do. So the Higgs field is needed to give mass to particles. When particles interact with the Higgs field, they make a ripple in the Higgs field, and that ripple is the Higgs boson. The bigger the ripple, the more energy the ripple is going to have. So imagine a tidal wave has a very large amplitude. It's very tall. It has a lot of energy. So the greater the ripple in the Higgs field, the more energy in that ripple. The more energy the ripple has, the more mass it gives to the particle, because E equals mc squared. So the greater the amount of energy, the greater the mass. So the greater the ripple in the Higgs field, and that ripple is the Higgs boson, the more mass is given to a particle. So what would you need to know for the exam? The Higgs boson gives mass to particles. That's it. Now, if you can understand all of this with the Higgs field and the Higgs boson and how it interacts, that's great. But just know that the Higgs boson is what's responsible for giving mass to particles. So here is the Standard Model, our current understanding of nature. And you'll notice that the chart is broken up basically into two parts. The upper part of the chart is the fermions. The fermions are the quarks, up, down, charm, strange, so there's 6 of them, and the leptons. So the electron and the neutrino that goes with the electron. So those are called leptons, and they're both necessary in order to create mass, matter. Okay, then you've got the stuff that's on the bottom. So the stuff that's on the bottom are the bosons. Those are the exchange particles. So if you look, you'll see the photon, which is what transmits electromagnetism. It's what creates the electromagnetic field. Then you've got the weak bosons. So that's what creates the weak nuclear field and the weak nuclear force. Then you've got the gluons, which is what's going to create the strong nuclear force. And then you got the gravitons, which cause gravity. And then down to the very bottom, you got the Higgs boson, which gives mass to particles. Now, if you want, read those other columns in it if you want to, but I just want you to see that we can explain nature by using the fermions and the bosons. All right, we're going to take another break. When we come back, it's time to unify. So we want to try to unify particles into one kind of particle, and we want to unify the four fundamental forces into one force. And so that's what we're going to do in our next segment.